Congratulations! It's day 90! This would normally be our last day of chem. We're fast forwarding to day 90 because we're going to miss out on the whole 10 chem inquiry lab. Too bad because it's a lot of fun to try to solve that thing. And you've now, of course, spent an entire 9 months, some of it remote, with a complete stranger. Stranger than strange, right? And all of that had to do with getting across what I think are the 6 biggest ideas from chemistry this year. So I want to see if you can figure out what those are. Of course, this is your very last required ETD, and then we go off to a long summer with those that we love. And these little guys, of course, are enjoying some chemistry. Oh, the fatty acids. Oh, the saccharides, because there's so much more chemistry to understand. Can't beat it, right? Ice cream. So here's what I want you to do. I want you to get out your ETD, skip forward to ETD 90, and then write down what are the 6 biggest ideas from chemistry this year. Can almost speak. And see if you can figure out what they are, right? You can flip through your ETD, which for those who are watching, it's an entry test daily. We've done them every single day. It's our entry test, right? See what you know. And what I want to see, of course, is if you picked up what we were hoping for this year. So let's see if you did it. Drum roll. Number 1, right? If we look at the year we started off with, what did we start off with? Oh, we started talking about these things called atoms. And if we look at those atoms and we think about Democritus cutting cheese and Rutherford with his sweet alpha particle gun, the BB models that we did, there was one part of the atoms that is the most important of all of them. And the most important part of any atom is the outside, the place where it can interact with other atoms, because the word that I said more than anything else this year was electrons. And the most important electrons, of course, are valence electrons. And then we started to figure out how these electrons determine their behavior using this weird thing that's shaped like a choo-choo train called the periodic table. Now, its beautiful shape allows you to make predictions if you think about the valence electrons, right? And all the electrons for that matter, but it's the valence that matter the most. So hopefully you got the idea that the valence electrons, formation of those octets and duets, depending on what you're looking at, can help you to predict what most atoms will do. And if you know your periodic table and you look at those beautiful columns and families, you can predict, if it's got 7 valence electrons, it's probably going to want one more. It's very predictable. It's almost like the universe makes sense if you really think about it, right? And they get in those sweet tug of wars with their electronegativity to fill those things, which, that's why you don't want chlorine near your eyeball. After we figured out how atoms worked, because atoms make up everything. You should never believe them. Then we started, of course, going to this thing where we looked at what you could do with those. Naming, right? Figuring out how you can make compounds with those. And you always got to neutralize the compound. And we learned some silly rules like the acid song. Ate ick. Gotta ike to us. Woo! And I ate big and got sick. Take a bite, you little wuss. Yeah, it's all in there, hopefully. We were scarring you for life. Well, what we were doing that, of course, was just so we could take those chemicals and start to see what would happen when we put them together with others. And they could change. They could chemically react. And that's why the next unit was all about this idea of chemical reactions, right? And one thing that we should notice is what goes in must come out, or what we call the law of conservation of matter. And when we look at that, that basically, states that matter cannot be created or destroyed, but it can change form. And one way that it can change form is in chemical reactions, right? We talk about physical and chemical changes. And when we look at, chemical reactions for a long time, people thought when you burn something, it just disappeared, you destroyed it, but it doesn't. That's why our planet is having trouble, because we burn stuff, it turns in smoke, CO2, and water, and heats up the earth, right? It doesn't just go away, it changes form. And really all a chemical reaction is atoms changing partners, right? They're doing the old switcheroo, where they can do it many ways, right? They like to make the gases, the water, the solids that make up the earth. That's why there's, those different layers in the ocean and all that stuff. As well as, of course, they like to transfer electrons. And in our final unit, we figured out they can transfer protons too. Acid-base reactions might have an impact on the ocean these days, right? Ultimately, you should recognize that the switcheroo means you can just rearrange them and make new compounds, and that's what chemical reactions are. It's the old dance partner swish, right? After we figured out that matter cannot be created or destroyed, we had to actually step into real chemistry and make it quantitative, which means we had to prove that was happening. And to do that, you had to measure the amount of atoms. And the problem with atoms is they're so darn small, you can't see them, right? We're just starting to be able to see the outside of them, at least the valence shell as we bounce electrons off them. So how do chemists keep track and make sure that every atom that goes in comes out? Well, it's easy. They don't count them one by one. They count by weighting. How do they count by weighing? The mole. Hopefully you at least realize that a mole is just the German word for a heap, a pile, as we called it throughout the year. Holy moly! Counting by weighing is a great way to keep track of stuff, and that's why the periodic table has the masses on it, so we can use their molar masses and their formula masses to keep track of how much is there. It's a very handy thing if you keep track of that pile, right? Atoms, electrons, and mole was like some of the major words I said besides ion this year. You know, an ion, it's a charged particle. It's either lost or gained. An electron has an imbalance of charge. Ion, keep my eye on you, right? And since, of course, the pile is so important, we wrote a song about it. And here it is. It's debuted for the world, the Mole Song. 6.022 to the 23rd. A whole lot of atoms, a number most absurd. Mole, 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 mole. I got some atoms in heaps and loads, an atomic dozen. Nobody knows. Mole, 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 mole. I found some numbers that I need to convert, turning piles to atoms, just like an expert. Mole, 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 mole. Ay! Yeah, you know I had to sing it the last day, right? Hope you sing it for the rest of your life. I know students 20 years ago who can still come back and they can sing it to me 20 years later, right? Now, with those moles, of course, we then moved on from this quantitative idea of chemistry and started to figure out how you could figure out what a substance was by using its mass. And then we moved into one of my favorite units of all, is this thing called gas laws. And the idea of gas laws was simple. It was all about putting up your dukes, right? We should recognize that gases and all substances on Earth are made of particles, and those particles can be molecules or atoms, but no matter what, they're moving particles. So if you ever want to figure out what matter is going to do, like whether there's going to be a thunderstorm today, or whether or not it's going to be a nice clear day, or why is there no suck in science? Because there's only push, right? And that push, of course, is the pressure that creates these collisions. So you can manipulate things like temperature, like the Earth is heating up, and that heating up would cause more pressure, when that would change weather systems on the Earth, because everything's connected. But those are just some of the things you can figure out if you understand chemistry and the idea that things are made of moving particles, right? Because if they stop moving, they probably stop existing. Oh, it's almost like they're made of energy, right? From the gas laws unit, we then went into by far the most important unit to understand life, chemistry, and the universe. That, of course, was the equilibrium unit. And that got across the idea of a very simple thing. Once we understood that there were moving particles that could run into each other, if they hit each other just right, they can react. And that's what a reaction is. A reaction is simply a collision. Collision theory tells us that there's a bunch of bumper cars out there. Turn them up a notch and you can actually get them into car accidents, make and break things, right? And we're breaking bonds. We're making bonds. And that all relates to how much energy is in the system. We should recognize that you can make something and you can break something, because every reaction is reversible. Otherwise, you turn into a bunch of smoke and you'd never, be in a living thing again. But you used to be smoke, and then a plant turned you into sugar through photosynthesis. It built you up, and then, your mommy ate that and, turned it into you, and you continued to eat it. And, there's all the carbon in your body that you then burn and make smoke through respiration. And then it starts to cycle again. It's almost like all of life is a reversible reaction. Good old pickleball, right? Until it eventually reaches equilibrium. And we should notice that equilibrium, the making and breaking at the same rate, is all determined, of course, by the rate of collisions, which is very much impacted by the temperature. It might be why we care about the temperature of the Earth changing so much. We then went into acids and bases, where we were simply looking at the idea that you can have proton particles that can, play some proton football. And they can, of course, exchange those protons back and forth. And if it's a strong acid, it throws it a lot in one direction, which is why it favors burning it. If it's a weak acid, then it doesn't throw it so good and tends to catch it back, right? Conjugates and stuff. Last part of this, of course, we've done a lot of chemistry. That's just a small piece of this, but those are the biggest ideas I'm hoping that you take away. Besides the one thing, we have done a massive number of calculations. I've sang lots of stupid songs to try to get stuff into your brain. And I did all that along with, trying to give you a tool that's very helpful in life. And you should notice, no matter what calculation or what idea that we were taking this year, we always did it the most efficient way, which is we did it in the easiest way for you to understand something and solve it. It's called do things in steps. If you use steps to solve things, you figure out what you got, what you need, and realize that units are usually more important than numbers, right? You can get all siggy with it. Nah, getting siggy with it. Never, sometimes, always. It's easy, right? Siggy figgies. What's the zeros that are, significantly harder? If you do things in steps and lay them out, you can solve anything in life, whether it's a physics problem in the future, whether it's AP Bio, if you got the guts to have another ETD with me, that would be fun. Or you could go on, to anything like environmental science, or, trying to figure out your mortgage, a house payment, a car payment in life. I even use steps to solve my taxes. Whoa, that's a handy tool. And if, of course, you draw those steps and figure them out by drawing them, it helps your brain. That's why we use SCAR so much, to think about analogies of car accidents, to figure out what was going on in chemistry, this world that you can't see, that kind of makes the whole world go around, right? Now, that, of course, wraps up the year for regular chemistry. This channel of YouTube, Neil's Science Spiel, will have a chemistry part, a biology part, an AP biology part, and a physics part, and I'll be doing some of those this year because I won't be traveling the world like usual this summer. Instead, I'll be hanging out with these little doofuses and making a bunch of videos to hopefully make the world a bit smarter so they make better decisions, right? Big hint for you, and I'm asking this, don't veg all summer. You're going to veg. You've been vegging for months, right? But the key thing is don't totally veg out because it would waste all of our hard work because you'll lose all those synaptic connections in your brain that we've been trying to form. And, do the smart thing. Scar yourself a bit this summer. I hope I've scarred you with my horrible songs and bad science puns and jokes. I do that solely because it works and it entertains me, right? Of course, with the scar part of that means you got to be curious. You got to look out and say, why is the sky so blue today? Why did a thunderstorm show up? Why is this booger green? Why is the grass green? Why is it turning brown? I wonder if I bought that kind of gasoline, would that change how well my car works? What is that smell in my car? Oh, it's the plastic going through a chemical reaction, right? Hopefully you realize, of course, that understanding chemistry can unlock a lot of new questions for you, and that's the beauty of life, is being curious. Normally this day we would honor our number one woodchucks of the year. That would be Olivia this year. She asked 56 great questions from period 7, so well done, Olivia. And she's going on to AP Bio next year, so you get a shout out there. If we look at this, of course, I hope that you have a wonderful summer and stay nice and safe. I will certainly be hanging out with my goofballs, and they'll be learning a lot of chemistry because they're stuck with a chem nerd dad. Yeah. So it could be worse, people. It could be worse. Thanks for dealing with me this summer. Hope to see you in the halls next year in person. That would be cool. Or on YouTube, where I can, have a bunch of songs on there to annoy your family with. And